Hello guys, welcome to my YouTube channel. This will be the first video of the robot kinematics series, that is Introduction to Robot Kinematics. So firstly, let's understand what is kinematics. Kinematics is a fundamental concept in robotics, crucial for understanding how robotic arms move and interact with their environment. In this video, we will introduce the basic of robot kinematics, including the core concepts of joints, links, and degrees of freedom, setting the foundation for more advanced topics. So, for this first chapter, Introduction to Robot Kinematics, let's understand what is robot kinematics. Kinematics in robotics refers to the study of motion without considering the forces that cause it. For robot arms, the goal is to control the position and orientation of the end effector. So, as you can see in this schematic diagram, this is called as the end effector, which is used for grabbing or holding things and objects. A robotic arm consists of rigid segments called links. So let's understand what is this L1 and this alpha 1 and this 3D of arm means. So firstly, L1 are the links, that is 1, 2 and 3, consists of 3 links and 3 joints, alpha 1, alpha 2 and alpha 3. The joints provide motion typically in the form of rotation or translation. The overall configuration of the arm based on the angles or position of its joints determines where the end effector is in space. And degrees of freedom. This refers to the number of independent movements the arm can make. That means the number of joints the arm has, it adds to the 1 degree, which means each joint adds to a 1 degree. So moving on, let's understand different types of joints. So there are primarily two different types of joints: revolute joints and prismatic joints. So revolute joints allow the rotation about a fixed axis. For example, this axis. For example, like a hinge of a door, hinges of a windows, etc. And for the prismatic joint, this provides the linear movements for like sliding of a windows and doors. So each joint contributes to 1 degree of freedom. For example, a simple 2-joint arm or a 3-joint arm has 3 revolute joints, namely alpha 1, alpha 2 and alpha 3, as shown in this diagram. Has 2 degrees of freedom, one for each rotations. In practice, most robotic arms may have 4 to 7 degrees of freedom. For instance, to increase the number of degrees of freedom, a robotic arm can have increased number of joints. To make the robots more versatile, you can increase the number of degrees of freedom, but it also adds the complexity for the kinematics. It adds complexity of the kinematics. Now let's look into robot arm configuration. There are mainly 3 types of arms: articulated arms, star arms, and Cartesian revolutes. For articulated arms, utensils such as human arms or multiple rotating joints. Okay. You can see human arms, multiple joint arms. And for SCARA, the full form for SCARA is selective compliance assembly robot arm. So this type of arms are basically used in assembly lines for providing compliance in certain directions. And for Cartesian robots, primarily has prismatic joints, as we looked in the previous section, that moves linearly along the x, y, and z axis. It's ideal for linear movements. It has motion along linearly along x, y, and z axis. So let's look into the further sections. I've just introduced to the future concepts, types of kinematics, forward kinematics and inverse kinematics. So in forward kinematics, it involves calculating the position and orientation of the end effector based on the known joint angles. For example, in forward kinematics, we can calculate the position and orientation of end effector, okay, based on joint angles. What it means, when the joint angles are given, you can calculate the position and orientation of the end effector. So, whereas in inverse kinematics, determining the joint angles required to place the end effector at a desired position. This is a bit more complex and often requires iterative or numerical methods to solve. It is used for determining the joint angles. To place the end effector at the desired position. It's just opposite to the forward kinematics, as the name suggests. So that's it for this video, guys. We'll further continue in the next video. Thank you.